Hi, we're going to talk about musical intervals. Intervals in music is the distance between two notes. They can be a harmonic interval, which is the relationship between two notes that are one on top of the other, or could be melodic interval, which is when two notes are sounding at different times. To understand intervals, we're going to make a list of 8 numbers, and we're going to draw a line in between 4 and 5, as we can see now. This divides the list in two equal parts of 4 numbers, and we're going to pay special attention to the number 1, 4, 5 and 8. Those will represent the perfect intervals. Now, with regards to the second, third, and the sixth and the seventh number, or in this case are going to be the names of the intervals, they are subject to be minor or major, as you can see here. They're never going to be perfect. The perfects are only the 1, the 4th, the 5th and the 8th. We also need to say that the position number 1 is usually commonly named as a unison. Now, with that in mind, we are prepared to build our first table of intervals. This table had to be memorized if we need to find out then the name of the intervals in the future. These are the name of the intervals and in the order. The first one is, as we said, the perfect unison. We're going to talk later how to name them, but at the moment we're just going to list the name at the order. Then we come with the minor second. We usually write it as M2. The major second with the uppercase M2, and then the minor third, the major third, then the perfect fourth, which we usually write it down as a P4, and then here appears a new one, which is something in between the perfect fourth and the perfect fifth, which is a diminished fourth or augmented fifth. It's a bit bigger in distance from the perfect fourth and a bit smaller than the perfect fifth. Then we have the perfect fifth, the minor sixth, the major sixth, the minor seventh, the major seventh, and the perfect octave. As you can see, what we were trying to say before is that the second goes through minor and major, the third the same, the sixth and the seventh, but on the first, the perfect unison, the perfect fourth, perfect fifth and perfect octave, they don't actually have the major or minor version of it. Now that we know the name of the basic intervals, we're going to try to measure them, and we're going to measure them through the number of semitones in between the two notes we are analyzing in every single interval. For example, suppose the violin and the flute are playing the same notes. There are two notes, but actually the same. Well, consider that we need to measure the distance in between the two notes. The violin is playing D, this one here, and the flute is also playing the same note. In that case, the distance in intervals in between these two notes is 0. There is no any semitone in between them. That allows us to say that those two notes are creating a unison. Then suppose we have two notes that are just one semitone away from each other, for example D and E flat. Those two notes are making a minor second because they are one semitone away from each other. Suppose I have a C sharp and a D sharp here. If I count the name of semitones in between them, I count 1, 2. That means that we are facing a major second. If, for example, I go from C to E flat, I count 1, 2, 3. That's 3 semitones. That makes a minor third. If I go from F to A, I count 1, 2, 3, 4 semitones. That makes a major third. If I go, for example, from B to E, I count 1, 2, 3, 4, 5. That makes a fourth. Now, what happens if we need to measure the distance between, for example, C and F sharp? Then we're going to have 1, 2, 3, 4, 5, 6 semitones. They're going to be 6 semitones away from each other. Then that is going to be called a diminished fourth. If I consider that instead of being an F sharp, that is a G flat, which is actually the same note, we're going to count, and obviously the number of semitones distance is going to be the same, 6. That's why we have either the name of diminished fourth or augmented fifth. That will depend on whether we call this an F sharp or a G flat, which is actually the same note from the oral point of view. If I try to count the distance between D and A, I'm going to get 1, 2, 3, 4, 5, 6, 7 semitones. That then allows me to say that between D and A there is a perfect fifth, and you go on adding here one semitone and you get the minor sixth, the major sixth, the minor seventh, the major seventh, and finally the octave. Let's prove that the octave has actually 12 semitones. For example, if we go from C to C, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 semitones. Now make sure you have this table here available either on paper or in your mind. And if you don't actually have it, you by remember the order of the intervals here, and then that this goes from 0 to 12, you can work it out yourself, but you'll need it in order to be able to tell the name of the intervals, as we're going to do now. An interval has a number part and a quality part of it. For example, if I say a minor third, the minor thing is the quality of the interval, and third is the number. In order to determine the number with accuracy in a written interval that we need to find out the name, we need to count the number of lines and spaces we're going through on the stuff. That's why we're going to call this stuff count, and we say that for example from C to A we're going to count 1, 2, 3, 4, 5, 6 lines and spaces. That means that this is going to be a sixth something. We don't know yet, but we'll discover it with the other part that we're going to do, which is the keyboard count. Now this we need to notice that we start from C, considering this number 1, and then we end up in A. We then have the keyboard count, which is the one that is going to help us to determine with accuracy the quality of the interval. And this is quite similar to what we've been doing about counting semitones. For practical reasons, for example, if we need to count it from C to A as we did before, we're going to count considering number 0 here. So we say 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and we discover that from C to A there are 9 semitones of distance in between them both. That is going to help us to determine whether that interval is minor, major, perfect, augmented, or diminished. Now that we have all the tools that we need to name the intervals, we're going to do some examples. Here we have the easiest one, which is, you can see the 2 notes in the same place. They're both C. This is a unison. Let's look at something more challenging, like for example this one. If we count it from the staff point of view, we count 1, 2. Remember, staff count goes from number 1, so we go counting 1, 2. Therefore this is a second. We don't know whether it's a minor or major. But now if we count from the semitone point of view, the keyboard count, we see that this is an A and this is a B flat. From A to B flat there is 0, 1 semitones distance. We know it's a second and it's got 1 semitone distance. We look at that and we look at that, and this is a minor second. If we look at this one here, from the staff counting point of view, we count 1, 2. This is also a second. Let's go and look at that from the semitone point of view. This is a B and this is a C. Therefore, from B to C there is 0, 1 semitone. Remember, the keyboard count starts counting from 0, so is 0, 1 semitone. Therefore this is also a minor second. What we see here is a melodic interval. Let's try to name it. From the staff point of view, if we count, we're just going to count 1, 2 steps. Therefore this is a second. Let's see how many semitones away from each other are. From B to A we count, this is B, 0, 1, 2. Therefore there are 2 semitones away from each other. That means that this is a major second. On this one here we have an harmonic interval, because they're sounding at the same time. The 2 notes are sounding at the same time, therefore it's a harmonic interval. Let's staff count it. 1, 2, 3. Therefore this is a third. I don't know what third it is yet, but it is a third. If you look now from the keyboard count, we go 0, 1, 2, 3. Now we know it's a third, so it's either minor or major, and it got 3 semitones of separation. That means that this is a minor third. Let's look at this one. We have that this is 1, 2, 3 staff count away from each other. That means this is a third too. This is like the other one is a third. But let's count the number of semitones of separation between the two notes. This is an A and this is a C sharp. We remember that when we count, keyboard count starts with 0. 0, 1, 2, 3, 4. This is 4 semitones away from each other. Therefore this is a major third, and it makes sense because this is a minor third. If we just add 1 semitone by sharpening the C, then we have a major third. This is also a harmonic interval. Here we have another melodic interval because the notes sound one at a time. Now we count from the staff count point of view. 1, 2, 3, 4. Therefore this is a fourth. Just make sure that the number of semitones that separates them is either 5 or 6. To be a perfect, it has to be 5 semitones away from each other. Let's count it. We have a G and a D. So we go from G. Remember that keyboard counts start with 0. 0, 1, 2, 3, 4, 5. Therefore, this is a perfect 4. You might have noticed that by looking at the number of semitones, for example, from A to C sharp, if I count 0, 1, 2, 3, 4, and then I look at the 4, and then I have the answer, it's a major third, then there's no point on counting the staff counting 1, 2, 3 to discover a third, because if I go here to the fourth, I'm going to fall on a third anyway. The reason why is necessary to also count the staff count is because later we're going to see more complicated cases in which the interval, the number of the interval doesn't actually match the number of semitones. Therefore we had to give them a different name. We'll see that later when we see more complex interval naming. Let's look at some more examples. Here we have from the staff point of view 1, 2, 3, 4, 5, 6th. This is a sixth. I don't know whether minor or major. Let's look at the number of semitones from G to E flat. We have 0, 1, 2, 3, 4, 5, 6, 7, 8. Therefore this is a minor sixth. What we have here is from 1, 2, 3, 4, 5. This is a fifth. Let's just make sure that this is a perfect fifth. From A to E is 0, 1, 2, 3, 4, 5, 6, 7. Therefore this is a perfect fifth. And then here we have from here to here staff count 1, 2, 3, 4, 5, 6 steps. They are 6 steps away. This is a minor or major sixth, I don't know. Perhaps if we look at the number of semitones from G to B flat, from G to B flat. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Therefore, this is a major sixth. Major sixth. And then if we look at these two, we have from here to here 1, 2, 3, 4, 5, 6, 7 steps from the staff count. Seventh, this is a seventh, one of these two for sure. And if we look at the note G to F, let's go G 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, a distance of 10th. Therefore, this is a minor seventh. We discussed before what is the point on the staff counting. What is the point of counting steps in between two notes when we just by counting the semitones, which separates the two notes, is enough for us to find out the name of a note. For example, we have we're going to prove that is not true, that is not always by knowing the number of semitones. We just can't directly go and relate to the left column here. For example, here we have an A and a C flat, which is A is here and the C flat would be here. So if we count 0, 1, 2, there are 2 semitones away. Therefore, this is supposed to be a major second. To be honest, if we ring these two notes at the same time, we're going to, from the oral point of view, it will be a major second. But from the writing point of view, this is a 1, 2, 3. This is a third. This is a third. It's not a minor third because it should have 3 semitones. Therefore, what kind of third it is? That allows us to speak about more complex intervals that we're going to be seeing from now on. In order to learn to name these more complicated intervals, we need to understand what happened to a perfect interval when is taken away or added 1 semitone. For example, here we have a perfect fifth. If this perfect fifth is reduced by 1 semitone, will be still a fifth, but it's not going to be perfect anymore. In that case, by losing 1 semitone, as for example here, that will become a diminished fifth, because perfect, when they are reduced 1 semitone, they become diminished. When a perfect interval, like once again a fifth here, is added 1 semitone, as we can see here, the C became sharp, so the distance now is 1 more semitone, then the perfect interval becomes augmented. So this applies for the fifth, applies for the fourth, and the octave, and also the unison. Let's look at how a minor interval can be altered. When a minor interval is losing, for example here we have a minor interval, a minor third, is losing 1 semitone, then it becomes a diminished interval. For example, a third. A third can only be major or minor, or, as we can see now, can also be diminished. When a minor interval, like the third, the seventh, the sixth, or the second, loses one semitone, then becomes a diminished. For example, this is a diminished third. And what happens to a minor interval when is added one interval, one semitone? Well, the answer is quite obvious. It becomes a major interval. That is a bit confusing because as you can see, the perfect intervals goes from diminished when it loses one semitone to augmented when it is added one semitone. The minor interval goes to diminish when when it lost one semitone, but goes to major when it's added one semitone. Like here, for example, we have a minor third that becomes a major third when we add one more semitone to the distance. When a major interval, like for example this major 6 here, loses one semitone, it becomes obviously a minor interval. For example, here it becomes a minor 6. Whilst when a major interval is added one semitone, becomes augmented, like here. A major 6th is becoming an augmented 6th. Now we must say that these alterations on the intervals is applicable to written music only, in the sense that from the oral point of view, a diminished third, for example, as we said before, will actually sound as a major second, and diminished sixth is going to sound like an actual fifth. So it's only when we see this written that we are actually going to be able to find these strange intervals. So this is how every single interval that we learn, the basic intervals, are going to behave when they are added or taken away one semitone. In the case of the unison, when we add one more semitone to it, it will become an augmented unison. It will sound as a minor second though, but from the writing point of view, it's going to be an augmented unison. By taking away one semitone to 0 doesn't make any sense. Therefore, the diminished unison is not considered to exist. When a minor second, who already has one semitone, is losing one semitone, it becomes a diminished second and will sound like a unison, but from the written music point of view, it's going to be a diminished second. And when it's added one more semitone, because it's a minor, becomes a major. Remember, the minor adding one semitone becomes a major. The same happened to the major second. When it's losing a semitone, becomes a minor, and when it's added one semitone, becomes an augmented second. Becomes an augmented second. An augmented second will sound like a minor third. That is from the oral point of view, but from the written point of view, we had to call it augmented second, and we'll have more examples later in which we understand why from the written point of view we cannot call it a minor third, but an augmented second. and so on with a minor third, major third, and here it's important to consider what happened to the perfects. The perfect 4, when it's losing one semitone, becomes a diminished 4. Therefore, doesn't actually become minor or major. It becomes a diminished, or when it's added one semitone, an augmented 4th. Then we have a perfect 4, the perfect 5th, in which is also the same case, diminished or augmented, and so on with the 6th. That is because it's a minor, and by losing one semitones become diminished, by adding one semitones becomes major, a major 6th, and will become a minor when it loses one semitone, and augmented when it is added one semitone. We have a 7th, the 7 major, and finally the octave, which is, remember, a perfect interval. Therefore, when by losing one semitone becomes a diminished 8th, by adding one semitone an augmented 8th. Let's look at some practical examples on complex intervals. For example, here we have the one that we saw it before when we started introducing this new topic. This is an A and C flat. Let's check it. This is the way we need to do this. We count it from the staff point of view first, and we see that this 1, 2, 3. These are 3 steps away. 1, 2, 3. This is the third. It might not sound like a third when you play it, but it is, from the written point of view, it is a third. Yeah. Therefore, we need to look at somewhere here. Yeah. A third has either 3 or 4 semitones according to whether it is a minor or a major. Now, let's count the number of semitones here. This is an A and this is a C flat, therefore it's 0, 1, 2. So we have a 2. And here's a minor third, has only 3. The one that we need to look at is a minor third that has lost one semitone. Therefore, one minor third has lost a semitone to become a 2 semitone interval is a diminished third. So therefore this is a diminished third. Let's look at this one. As always, we count the staff, counting the line first, the line and spaces first. 1, 2, 3, 4, 5, 6, 7. This is a 7th. Once again, it might not sound like a 7th, but it is a 7th. And you know that it's not going to sound like a 7th because that E sharp is going to be sounding like an F. Therefore, these are going to sound like an octave. But from the written point of view, this is a 7th. And we'll count the number of semitones away from each other. We have F here and E sharp here. Therefore 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 semitones away. Let's look at the 7th and what happened to the 12 semitones on the 7th. Well, it's actually a major 7th that is being added one semitone to become a 12 semitones 7th. Therefore, this is going to be an augmented 7th on augmented 7th. Let's look at this one here. We have that this is a 1, 2, because we first of all count from the staff point of view, which is going to give us the number of a interval. When we said minor, remember major, perfect, augmented, diminished, that is the quality. Now we are just wondering about the number. This is a second. This is a second, yeah, and we need to count the number of semitones that separates these two notes. It's an F from a G double flat. It is the same note. From the oral point of view, it's going to sound exactly like the same note, but from the written point of view, is a second, and a second with 0 semitones. Therefore, let's look at the second. It's a second that has lost one semitone to become a 0 semitone second. That's going to be a diminished second. 1 minus 1 is 0. Finally, let's look at this one here. We have from the staff point of view, to discover the number of an interval is 1, 2, 3, 4. We know this is a fourth. Now, once again, it might not sound like a fourth. When you play it, it will sound like perhaps a third, major third. But from the point of view of the written music, this is a fourth, and a fourth that goes from A to D flat. Let's count it. Count the number of semitones now. 0, 1, 2, 3, 4. If you look at the perfect fourth, it has to have 5, no fourth. So if it has 4, it's because it has lost a semitone. Therefore, this is a diminished fourth. Let's look at 2 more examples here. For example, we have here one with double sharp. This is, let's count from the staff point of view, the number of steps. 1, 2, 3, 4, 5, 6, 7th. This is a 7th. If you look well, it's not going to sound like a 7. It's going to sound like an octave, because that is actually sounds like an E. But from the written point of view, which is what we are interested here, this is a 7th. And let's count the number of intervals they are away from each other. For example, this is an E and this is a D double sharp. So we go from here 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is a 7th that has 12 semitones. The only way to think about 7th with 12 semitones is by adding 1 to the 11. That would be an augmented 7th. Now we have this one here. It's a G that we assume is a natural G and a flat G. Then we know it's an octave, but we just in case we're going to count it. 1, 2, 3, 4, 5, 6, 7, 8 is an octave. It's an octave, but we know that it's not a perfect octave, because this one has a less -1 semitone here. but we're going to still count it on the keyboard counting from G to G flat. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Therefore, this is an octave with 11 semitones. Then it's 12 minus 1. This is a diminished octave. A diminished octave. Remember, when you staff count it, you always start from number 1 on the origin, and when you keyboard count it, you always put number 0 on the origin, and then you move. Finally, we talk about compound intervals. What happened to an interval where it exceeds the eighth? For example, we have these two intervals here. These are actually wider than an octave. What we do is just take the top note and drop it 1 octave. This is a G. We drop it to the other G here, and then we can easily see that this is a fourth. Well, if this is a fourth, therefore this is a compound fourth. A compound fourth that also can be called perfect 11th. This is a compound perfect fourth, which is also a perfect 11th. It's either way you can call it, but obviously by calling it compound perfect fourth is easier to understand. On the other hand, sometimes most of the time when we're talking about harmony and things like that, we just call it a fourth or perfect fourth, but we don't actually mention the word compound. We assume that is present there. For example, another two notes here, a C and an A. Well, a C and an A, we just drop that top note down 1 octave, and we can see that this is a major sixth. A major sixth in this case is a major sixth, a compound major sixth, therefore is a major 13th. Major 13, so we have two ways of calling it, but as we said before, we usually just call it a major sixth, even if they are distant from each other. Well, I hope you enjoyed these educational videos, and if you have any questions, just place it down in the comments part of the video, and I will be pleased to answer to you. Thank you very much.